Hello and welcome back. In this section I want to talk about substitution rule, and this is a very important part of integration, and so you'll see how I'll try to explain how the substitution rule and the chain rule in derivation go hand in hand. You're basically using substitution rule to back out the chain rule. So I'm going to start off simple. This is going to be a multiple part lesson, and I'm going to start off simple. And then we'll work into some more complex iterations or some more complex problems. But I think in this video I might try to cover two examples real quickly. So first example I want to share with you is just a really simple problem where you have the integration of something, say like x squared, and in the parentheses you'll have, see, x cubed plus 6. And then let's raise that to a power there, dx. So the long way to perform this integration is, since you see there's nothing really too complicated, we could take this area right here and then just continue to, that's 6x to 3 plus 6 x to 3 plus 6, and then just continue to multiply that out, and we would get to some huge polynomial that would actually be integratable, but we would save so much more time just by using the substitution rule. And so how do you want to think about this? So easiest way, this is why this is such a simple problem. If you look here, you have x to the third, and then if you look here, you have x squared. So you have something inside of a parentheses or inside of a square root or something like that. If you remember, when you do substitution, you pick something that'll be your u. So usually you look into that parentheses or square root and you start there and see if that'll work for you. And I can, just by looking at this, is you have u, and then the next step is to find the derivative of u. And so I know that if I find the derivative of x to the third, it's going to be something that's x squared. So that's, I'll show you, you'll see in just a second why that's going to be important, because I'm going to be able to cancel that out with the dx. So also, good bookkeeping and good organization is important on this one as well. You'll see why in just a second. So first part, I'm going to select something that's trapped inside a parenthesis, and this is raised to a power, so it's trapped. So I'm going to assign that to my u value, plus 6. Okay? And then my derivative of that is just going to be 3x squared dx. It's important to include the dx here because we're going to solve for what the dx equals next. So if you look, I have a dx here. Typically, we tend to neglect that that's actually there, but it's important because we need to substitute that dx for du when we go substitution. We want everything to go from x to u domain, okay? And so the integration here, I'm going to start replacing things now. So I'm going to take this one step further before I do that. So I'm going to solve in terms of dx and see what happens. So dx, all I'm doing is moving this to the other side. So I'm going to have du divided by 3x squared. Okay? So then I'm going to take the long road. I'm not going to take any shortcuts here. So I'm going to have x squared, just from that guy right there. This guy becomes u to the 8th power. Okay? And then my dx, I'm going to substitute in this. So this is going to become du divided by 3x squared. Okay? Next step is to simplify. So if I'm in the u domain, I want to get rid of all of my x's. So in this case, because the problem is easy, everything, I'm looking at this guy right here and that guy right there. Those guys cancel out. And then I'm also left with a 1/3. If you can see there's a 1/3 here. It's just a constant multiplying against that u, so I can throw that out front. There. And so now what I'm left with is my x squareds cancel out, and all I'm left with is u to the 8th and then du. And so from there, it's just, we know how to do that. So substitution rule is going from something you don't know how to do to simplifying it to something you do know how to integrate. So if you look at this now, and you say 1/3 over u to the 8th, that's easy enough. This goes to, I'm going to say the 1/3 is here, okay? And then this guy becomes 1/9u to the 9th. And then we have the plus c. Okay? So then this guy simplifies out to 1/27 u to the 9th plus c. Okay, so we're almost done. So we just have to go back to the x domain. So we've got to replace this u with the x domain side that we had over here in the original substitution. So we're left with 1/27 x to the 3rd plus 6, okay, plus c. And that is our answer for that one. So simple enough if you look at that. So I'll just go one more problem deep so you can kind of see just another quick simple example too. In this case, we love to throw e to the exponents and natural logs at us. That's a good way to test knowledge. So I'm going to throw the problem out where it's going to be, let's just say, take the integral of dx over, just say 4 minus 3x. Okay, so looking at that, so you can think about it as what's in the denominator is kind of trapped. And so let's start with assigning u to 4 minus 3x. My du is going to be equal to just a negative 3 dx. Okay, and then I just solve for dx directly, so it's negative 1/3 du. Okay, from that point we can substitute into the original problem to go from x to u domain. So my u goes right in the denominator. My dx becomes negative 1/3 du. Simplify that a little bit. I'm just going to throw the negative 1/3 out to the front, and I'm just going to have u du over u. So if you look at your tables of things we know how to integrate, you'll know that that one right here actually becomes the natural log of u. And it's actually the absolute value of that. So we'll just carry down the negative 1/3, and we'll do good bookkeeping because this is a indefinite integration plus c. Okay, so that's simple enough. So we've got that. Now we can substitute, go back from u to x, and we have negative 1/3 ln 4 minus 3x plus c. And that is your answer. So basic steps that we're looking at is you're trying to look into the parentheses or something inside of something and see if there's a component of that on the outside. So you're looking in and you're looking and out of whatever it is, parentheses or square root, or if you have a trigonometric function such as, let's say, cosine, that would be the inside of something, or the denominator at the bottom of the fraction here. So something you want to group together, you're trying to get from something, a form that you don't know, to a form that you do know. So sometimes it's a little bit of trial and error, especially as the problems get a little harder, but these are designed to be easy for you to walk through. So that's part of it. Let's see. And then you have to do a little bit of plug and chug, I guess, going from your X domain to your U domain. Something to remember. Then you try to cancel things out to make life a lot more simple for you, and then you just integrate what you do know. So, okay, so that's the end of part one, and I'll put some more parts together so that we can cover some more complex problems. But I hope this is a good start for you.